In this video, we'll discuss Venn diagrams. For this class, we'll use Venn diagrams both in the logic section and in the probability section. What makes a Venn diagram is, what we use Venn diagrams for are to represent sets and relationships among those different sets. A typical Venn diagram is made up of a universal set, which includes everything within the rectangle, along with this possibly as few as one set we'll generically call the sets A, or later A and B, and a way to distinguish where things are in set A or outside of set A. In particular, the things inside of the circle A are considered to be within A, such as the X here. Outside of the circle A, like the O here, they're part of the universal set, but they're not considered to be in A. And that's how we mean things in these Venn diagrams. Your book goes through the 4 different ways Venn diagrams can look when there are exactly 2 sets involved. For instance, there can be a place where the objects in the sets overlap. They have an intersection there. There's part in A, part in B, some that are in both. There can be no overlap. This is called disjoint or mutually exclusive. They can have one of the sets, in this case B, entirely within A, or they can have A and B represent exactly the same set of things. So we can draw Venn diagrams in a few different ways to represent those 2 sets. Again, some basic things to pay attention to. Everything in the box is considered to be part of the universal set. Now let's look at some examples of using universal sets. In this example, we're asked to draw a Venn diagram to represent the following situations. In A, we're told out of 20 people, 13 are wearing tennis shoes, 8 are wearing baseball caps, and 6 are wearing both, or doing both. We've got our Venn diagram over here to represent all 20 people. The universal set here represents all 20 people. We've got 2 sets. We'll call one of the sets T, those wearing tennis shoes. One of the sets B, those wearing baseball caps. I'll note there are some people doing both, so they certainly will have an overlap. So I'm going to draw T and B together like this. And when I do a problem of this sort, what I really want to start with is the 6 people doing both. I know those people are doing both. Alright. Taking this further, there are a total of 13 people wearing tennis shoes. 6 of them have been accounted for here in the intersection. So there are 7 out here. And what that 7 is referring to is there are 7 people who are wearing tennis shoes who are not also wearing baseball caps. Alright, there are 13 people total who are wearing tennis shoes, which is what this represents. There are 2 remaining people who are wearing baseball caps and not wearing tennis shoes. I've accounted for so far 7 plus 6 plus 2, or 15 of the people. There are 5 more people included in this universal set of 20 people that would go out here in the Venn diagram. In B, we're told the set E represents the even numbers contained within 1 and 6, that is between 1 and 6, including 1 and 6. And set P represents the prime numbers within that range, that is within the range from 1 to 6. Recognizing that there's some overlap between those 2 sets, let me draw this as E and P. The universal set here is somewhat implicitly the numbers between 1 and 6. And in this example, somewhat different than I did last time, I'm going to list out the elements in there. If I go through the numbers, 1 is neither prime nor even. It's going to go out here. 2 is even and prime. It'll go right here. 3 is prime but not even. 4 is even but not prime. 5 is prime and not even. 6 is even and not prime. So listing out all of the elements there in the universal set, I've got my Venn diagram drawn. For example C, we see that set E represents the even numbers contained within the set from 1 to 6, and set O represents the odd numbers in that set. And thinking about this, even numbers are never odd and odd numbers are never even. So I can draw this Venn diagram this way. The even numbers here are 2, 4, and 6. The odds 1, 3, and 5. And there's my Venn diagram. There's no values in the universal set that are not contained within either of those sets here. In D, we're told that the universal set is all UNT students. That the set M represents the students in Math 1580, and the set J is the UNT students who are wearing jackets. Here we have part I. We're told Seth is in 1580 and is wearing a jacket. Let's put an X where Seth is. First drawing the appropriate circles in this Venn diagram, We see the generic setup should look something like this with set M and set J. Seth is in 1580 and is wearing a jacket. I'm going to put an X there. That should be in this intersection portion right there, which if the marker was working would be showing up with an X. Let's put it in blue. And we see that's where the X would go to represent that Seth is right there. The second part of this example tells us that Naomi isn't in 1580 and is wearing a jacket. Let's put a Y where Naomi is. So she's not in 1580, she's not in set M, but she is wearing a jacket. Naomi should be where that Y is right there. The third part of this example tells us Cindy isn't in 1580 and isn't wearing a jacket. I want to put a Z where Cindy is. Right, since she's not including either part of that, she is part of the universal set of UNT students. The Z should go outside of those two circles, what I call the MasterCard part of the area right here. Z's out there. Looks like where Cindy is. Have fun with logic.